one for next week and also review the notes I will send. Now I'm going to put some assignments in the platform. Okay, Adamaris has the TI-84 Plus calculator. It's very different, Adamaris, but I do have some notes for that too. If you do want to stick with that calculator, I'll send those. Okay, if anybody wants the notes for TI, what was it, HP 10B?
Thank you.
And the TI A4. I don't know if I have the plus, but I have the TI-84. Just have to email me, okay, so I can send them to you. The only problem is I can't guarantee you, those are going to be useful if you do want to take a CFA exam. So you're not going to be able to take those in on the exam, and they're distinct. Like the calculators are distinct for some of the calculations. In particular, the calculation of the internal rate of return. I think the easiest calculator is probably the HP 10B2, but I don't use it because, like I said, I'm trying to invest, make it a good, worthwhile investment that this calculator is actually going to be useful. Or you can sell it. You can sell it to somebody who does want to take the CFA exam. All right, so okay, so let's go. So anything that I'm saying right now, if you're using the other calculators, I won't be able to show you, but I mean, you can fidget around. Maybe what I'll do. One moment. I need to. Just realized my cables is out. So if I send you those slides, I don't know if they're exactly what I'm going to show you right now. But anyway, email me if you guys want these slides for the other calculators. And I can send them. Send me an email. All right. Okay, you can see my screen.
Yes.
Do you see?
Yes.
You see my projection?
Yes, we can.
Okay. All right. So this is a set of notes. Again, if you want another calculator's notes, the only two that I have is the HP 10B2 and the TI-84. I don't have any other calculators, and it needs to be a finance calculator. Okay? All right, so for the calculator, we're going to learn about all these things. We should be able to finish this in the first two classes. We'll find out. It's 3 hours, so 6 hours. These are setup instructions. We'll get back to this after I introduce the concept that we're going to cover. I'll come back to this sheet and then this one too. All right, and this one too. All right. So we begin here. So I was telling you about 2 types of people, and that's at least 2 types of people have to exist for this. And we are going to discuss the time value of money. We are going to discuss that price that I mentioned to you, the price that someone is willing to pay and another is willing to or prepare or requires to receive, to give up or trade off consumption over time. That's the basis of what we're going to do. And so what arises from there is the time value of money. This, in effect, changes our perception of money. So we can say, well, let's just look at the timeline first. This is a 2-period model. So we're going to begin with a 2-period model, and it's pretty straightforward, it seems. But the one thing I want you to be aware of is that at any point in time, you can see your position in 2 ways. You can see it as the end of something and the beginning of something else, rather philosophical. But in fact, this is reality, and you're going to see that we can make choices about how to visualize or perceive cash flow. So we're going to talk about cash flow in a minute. Okay, so I'm here, and this is, we'll call this time 0 or today or now. But in fact, it's just a point of time of interest. And from this point is the beginning of period 1. Period 1 transpires and ends with a mark. This 1 refers to the end of period 1, but it also marks the beginning of period 2. And we work through period 2 and we get to the end of period 2, but the beginning of period 3. All this very straightforward, so it seems. And you're going to find that you need to know, I mean, I can take this, I can zoom out and look at this model and move to a 2-period model to any point in time in the future or in the past as well. Sorry, someone's throwing fireworks. So here we have the 2-period model, and I'm going to introduce the idea of an interest rate. So what is this interest rate? This interest rate has been determined as appropriate for this problem. It's what you're willing to forego $1,000 for today with the promise of receiving 8% return in each of the 2 years for this investment. Okay, so you can, in what we're talking about, we're going to be able to invest or lend. So here I'm going to talk about investment. So how much will that $1,000 be worth in 2 years? how much will be simple interest and how much will be compound interest. So you've probably seen these concepts before, and I'm taking a very simple example to work through to elaborate what's happened. So can you tell me, so what we're going to do is first calculate each of these mathematically, and then I'm going to show you how to solve for this using your financial calculator. What we're going to solve for is the future value, FE. Anyone? So how much would $1,000 invested today be worth in 2 years?
1,166.
And how much cents?
40 cents.
40 cents. So that's correct. Okay, so how did he get that?
First one is 8%, so it's 1,080, and then do it again 8%, and you'll get the last one.
All right, so what happens is after 1 year, you're going to see your principal grows by 8%. So you're going to earn back the 1,000, and then on the 1,000, 8%. So this becomes 1,000 plus $80. And then it's reinvested. It's reinvested as this total amount, and another 8% is earned. So before I go to the second year, what I'm going to show you is I'm going to ask you, can I write this like this? It's not the same thing. It's like I factored out 1,000. So this says the principal amount of 1,000 is returned. That's what the 1 stands for, plus 8% on the 1,000. Is everybody okay with that? I can also write that like this. So this is how I'm going to show that it grows or accumulates. So this is called the accumulation factor. The accumulation factor, and if I reinvest this amount and I keep this pattern going, then I just have to put another factor of accumulation on it. Is that right? So I've taken the 1 from the first year, and then I accumulated another year. So I can rewrite that, and we see a pattern emerges. At the end of year 1, there's 1 period of accumulation. At the end of year 2, there's 2 periods of accumulation. And this is the basic time value of money relationship between the present and the future. Any questions? So I went from this plus 80, and I use an accumulation factor, and then I use it for 2 periods. In fact, finance was done before calculators and computers were everywhere. Tables were created with accumulation factors and something we're going to learn about later. Another kind of factor, and tables, very thick books of tables were created to facilitate calculations that were very common. All right. So, so then someone just has to do a multiplication between this and that amount. Without a calculator, you can see it's very time consuming. All right, so this is the answer. All right, so that we've got the answer to part A. So A is 1,000. So how much is it worth? So 1,000 becomes $1,166.40 in 2 years. I'll write that a little better because you can see. All right, so how much of that is simple interest? And we can talk about what simple interest is. And how much of that is compound interest? So what are those two concepts? You may have heard of them before.
Is it the simple interest would be the 80 and then the extra money you're doing would be the difference, the compound one?
Okay, you're close. All right, so you're close. It's something about this amount here. So the total interest is $166.40, right? That was all interest. Now, part of that is found as just taking 80, so $1,000 times 8% for 2 years. That's a simple interest, which is 160. Well, if you do the math, that's 80 times 2, right? It's 160. So in general, we can write it as we're going to refer to 1,000 as the principal amount or the present value. We're going to refer to the interest rate as I. And we're going to refer to the 2 years as T or time. You're going to see we're going to do that in our formulas. Okay, so in general, this is how you find simple interest. It's just multiplication. But in fact, when you look at our formula, we have a power here. We have a power function. Like this is affected by the a factor in the exponents. So we've completely neglected that. I mean, it's not that far off, you know, it's just $6.40, and that would be the compound interest. So what is that? What is the compound interest? It's total interest minus simple interest and it's going to be 166.40 minus 160 equals $6.40. But what is that? Where does it come from? And this is what.
Basically, is it the interest on the previous interest earned?
Exactly. Very good. Yeah. So it's the interest on the interest. It's 80 that gets another 8% on it. So it's the interest on interest. And we just did this for 2 years. Imagine it's not a big deal for 2 years. But think about a mortgage. How often is a mortgage paid?
Monthly.
So monthly payments come with monthly interest. So you're paying interest on interest for 12 months, and that's just 1 year. How long is a mortgage? Could be
50
25, could be 30 years, right? It could be a long, long time. So hundreds of payments, hundreds of compounding of interest on interest. So it can be really large. So this number you could find, you get this out of the way here. That's how you get $6.40. It's 8% on 8%. Interest on interest. It's PV times I, and now that's where the T comes in, the power. So simple interest is multiplicative. Compound interest is with the power. And with many periods, this becomes, can be much, this can blow up. This can be very high. Okay, when you think about 300, a power 300, it's much worse. It's much more than times 300. Okay. All right, any questions? So we learned, so you probably knew about interest, you understand. So interest, this 8% is being used in this problem because although there's many interest rates out there, this is the rate that this person is willing to invest $1,000 at, okay? And notice I didn't say anything about risk. I didn't say there's any uncertainty. It's guaranteed they're going to get that money. So this is the simplest example I can give you. If I add in risk, that's a whole nother thing. But 8% is what they're willing to give it up for. All right. So I just have here, I just carried out the calculations, and this is what I call the basic time value of money formula right here. Future value at time t is equal to the present value at time 0 times accumulation for the duration of the investment. So I have all these defined on the previous page, and I'll go back. But first, I'm going to show you how to use your financial keys to solve this problem. So if you have the TI BA2 Plus, Texas Instrument BA2 Plus, what you do, I'm going to show you because I have it on my calculator. I'm sorry, I have it on my iPad. So are you ready? So N is 2. So I'm going to use the third row. You see these? These are the time value of money keys. This is the time value of money row. And to be sure that it's clear, I need to clear TVM, clear time value of money. Right, so maybe there was something in there, so I want to clear it. So I have to hit the second key and then clear TVM. And then I begin putting the numbers in. The number first, then the key. So 2 years. Interest, should I put it in as a decimal or as a whole number? What do you think? Or anybody knows how to use this calculator? It turns out for the financial keys, you use the whole number. So you put 8. I mentioned I was going to talk about cash flow. So what we have to be aware of is cash flow. Money coming in and money going out. So we call it, we say out of pocket if it's going out, or in as a revenue. So it's either a revenue, it's a positive cash flow, or it's an expenditure, it's a negative cash flow, or it's an investment, it's a negative cash flow. Okay, so in that moment, it is seen as a negative cash flow that I'm investing in this opportunity. So there's my negative 1,000 and I press present value or principal value. Then in terms of payment, there is no payment in this problem. There's just a lump sum investment. We'll learn about payments later. So I put 0 into payment. And I'm done. I've entered all values. I'm going to ask to compute now. Compute. You see me clicking compute. So compute FV, and there's the answer. Anyone who would like to see that again?
Yes, can you do it again?
Yeah. All right, so first I'm going to clear TVM. Second, clear TVM. Then I hit 2N. Eight, interest, I by Y. It's interest per year. The present value amount is 1,000 with a negative because we're investing, so it's a cash outflow seen as an expenditure. So that's PV. And then we have no payment, 0 for payment, and we ask to compute FV. There's the answer. So if some of you have this calculator and you don't see 0.4, it's your calculator might need more decimal places. So let's see, let's add more decimal places onto the calculator. The way to do that is to, and this is in the notes as well, the pages that I skipped at the front. So second, format. Now dec stands for decimals. Mine is already set to 9, so you put 9, enter, and it should be fine. So now it should show 7 divided by 9, 9 decimal places. Okay. So let's see what I promised I would explain the variables. So we have n in our calculator is really the t in the formula. So whatever the case is, the calculator uses n and we use t. This has not been standardized across formulas and textbooks and calculators. The interest rate is I. PV is the present value or the principal amount. And notice that I put the subscripts. That's going to become relevant later when I use different points in time. But this is from today to the end of the duration of the investment. Payments, this is for a constant payment that occurs at the end of the period, which we did not have in this problem. So we just put 0, we had to enter 0 there. And because this row, it facilitates many formulas that are programmed in. To turn that off, you have to make it 0. And then the future value. Also for the setup, for the sake of setting things up, we don't have a payment right now, but when we do have a payment, this will be relevant. So what we need to do is set up the calculator for one payment per period. We don't want multiple payments per period. So all the formulas that I give you are arranged so that there's only one payment each period as defined by the problem. So we're working in years right now, so there's only one sorry, there's going to be 2 periods of accumulation. So anyway, we'll talk about payments later, but what I want to do is set up the calculator for one payment per period. And you can see that here, if you hit second function and P by Y, there should be a 1 there. If it's not a 1, you need to set it to 1. You need to hit 1, enter. Now there's other options, but we just care about the P by Y. Right? So that's period, payments per period. But it should just be 1. All right, so let's go back. If you see that you're getting different answers than me, it could be one, it could be possibly that you don't have a 1 there, the P by Y. All right, so we solved one problem. We did it analytically. Okay, we used our calculators. We used our basic understanding of mathematics. And then I introduced the time value of money relationship. And we use our finance calculator for the first time. We understand the idea of cash flow. For whatever reason, the calculator needs to keep track of what's going in and what's coming out. Okay, the way that it solves problems, it needs to know. And finance calculators work like that. All right. These are just okay, so those were just summary pages. Make sure you had the right answer. All right, so we've talked about the time value of money relationship. I'm going to take this relationship, you could call it a formula, but it's a relationship. How do you apply it to this problem?
Future value equals PV, which would be the $1,000 multiplied by 1.8 times 2.
Times 2? Or try again. Tell me again. Where's FV? Okay, let's go through this. What is everything we have here? So this is I, right? 8%. So that's true. See? And what is this amount here?
The future value.
Yes, so that's the future value. So that's going to be FV2. Okay, and then 2 is T. So what's missing?
Present value.
Right. So the relationship can be exploited. There are 4 variables here. If I know the other 3, I can find 1. Right? So as long as I know the other 3, I can find 1. So the first problem was the basic time value of money relationship where I know all of these on the right, so I can find the future value. I accumulate to find the future value. Here is a different question, so I know, oops, sorry, too far. So I know that $1,000 is to be received if, it doesn't say that here, if I spend how much? So you can see this as an investment opportunity. How much are you willing to spend to get 1,000 at the end of year 2? So what is that? What is that $1,000 worth to you? See, what's the value of it? What are you willing to pay? That's the way you're saying it. %8 is your interest rate. So that's already been sorted out. How much are you willing to pay to get $1,000 in 2 years? Mathematically, I can plug these values in. I can do this as 1,000. This one I don't know. And then 1.08 to the 2. And I think I didn't see who was talking to me, but he had it kind of right. Yeah, Andrea, I'm recording. Yeah, yes, it's recording right now. So you can catch it here in Teams. It'll save here. You can come back and see it. It'll be in the chat. It'll appear in the chat. Okay, the recording. Okay, so to find this, you do algebra where PV0 is 1,000 divided by 1.08 squared. And I think that's what first person who commented was meaning to say. So mathematically, we can use this same expression to find or solve for a different variable. So mathematically, how do I solve that? I can just do 1,000 divided, so I can do that here. 1,000 divided by 1.08, and I can square it on the bottom to get the result. So it's worth $857.34. So that's the most you'd be willing to pay to get that. That's one way to look at this, okay? Where I say, so $1,000 in 2 years is worth 857.34. So now we have an equivalency over time. $1,000 in 2 years is worth 857.34 today. I would be willing to spend that at 8%. If that's my rate, I'd be willing to spend that to get the $1,000. What if, okay, any questions? Any questions about that? Well, let's do this on the calculator, financial calculator, and then I'm going to approach this in a different way. So for the finance calculator, you would enter the same values, 2 into time or number of years, 8 into interest, PV we leave blank, we put 0 into payment because we're not going to use that, we need to override it, and 1,000 into future value, and we compute PV to get this amount. It will come out as a negative, implying you have to spend that. So the calculator's telling you what to do, right? You've got to spend that out of pocket to get the 1,000 in the future. This term is called a discount factor. So we had the accumulation factor before. Now this is called the discount factor. And we discount to find the present value. You see, what's a discount? The discount is, a discount has a lower price, right? So it's a way we use the word discount. And that's the discount factor. All right. Okay, we're going to take a 5-minute break. When we come back at 7:28, I'm going to ask you for another interpretation of this problem. Okay, so let's resume. Oh, I'll just make it go till 7:30. Okay, we're 6-minute break. I'll see you back here at 7:30. Okay, I'm back. All right, so here's another way to think about this. Just reading this, it doesn't specifically say anything about an investment. It just asks for the value. It just asks for the value. What is it worth to you that you will receive $1,000 in 2 years? So think about it. If you've ever heard the word leverage, have you heard the word leverage before?
Yes.
Yes.
Okay, so it's a good opportunity in a very simple case to explain what leverage is. So I know I'm getting $1,000 in 2 years. And that's guaranteed. I didn't put anything about uncertainty here. It's guaranteed $1,000 in 2 years, right? So I can use that as leverage. I can say, well, since I'm getting 1,000 in 2 years, and I know that 8%, 8% is my interest rate, then I could borrow against the fact that I'm going to have $1,000 in 2 years. How much can I borrow?
Can you repeat that, Professor?
Okay. The question is, how much can I borrow today? How much could I put in my pocket right now, knowing that I get $1,000 in 2 years?
Would you just
It's the
pocket
same
1,000
mathematics.
today?
Yeah, how much could you put in your pocket today, knowing that $1,000 is coming in 2 years? I know I'm going to have 1,000. How much could I borrow right now? Well, I could borrow $857.34. That's the value of it today. And then use it, do whatever I want with it. And then I know I'm getting $1,000 in 2 years and pay it back. So this is the idea. This is finance at work, right? So this is the benefit of understanding time value of money. Not only would I be willing to pay to get the $1,000 later, if I know $1,000 is coming, what can I possibly do? What value does that have to me today? Well, I could borrow and when I get the $1,000 in 2 years, pay back the loan. The loan would be at 8% because that's the only rate that exists that I'm using. The loan is at 8%. So this $1,000 will pay it off. Now, what could you do with that in the interim? Well, if 8% is the only rate, I mean, you can just spend it, do whatever with it right now. But in fact, in reality, knowing that money's coming in the future and borrowing against that, hedging any kind of risks, you could use that money to try and do something else. And this is what banks do. This is what insurance companies do. This is what funds do. Okay, they leverage. So this is a very basic example. Do you have any questions about this? So when I read this initially, I kind of had to force it to say, how much are you willing to pay? Because it doesn't say that, but that would give this result, right? But you get the same result mathematically saying, what is $1,000 worth to me today? Well, today I could go and comfortably borrow $857.34, knowing that the $1,000 I'm getting will pay it off. Okay, so think about that. All right, so I've done this problem entirely. We've talked about future value. We've talked about present value. That leaves two more variables. Using the time value of money relationship, find the interest for this problem. Find the interest rate. So interest rate, I'm calling it I, the interest rate right now, and really there are a variety of names given different settings, different scenarios, or different contexts. It's still mathematically the same I, okay? But it's going to take on different names. So for here, we can refer to it as the rate of return on the investment for a financial security that sells for $900 today and it pays $1,000 in 2 years. What is the return on this investment? So it's an interest rate. It's the intrinsic or implicit interest rate. And you're going to solve this problem. Future value 1,000, present value 900. Mathematically, you can solve this. Mathematically, we could solve this on the side. 1,000 is 900. 1 plus I square. So using algebra, isolating, trying to isolate I. I is equal to I'm going to take 10 divided by 9. So 10 divided by 9 equals square root minus 1 is 5.409%. Should I do it again? N divided by 9 equals square root minus 1. So 5.409. So I solved that analytically, right? Just using algebra. And that's not so difficult. However, there are problems that we're going to solve that are more complicated for isolating I, and that happens when we're looking at more periods. We're just looking at 2 here. If we have more periods and we're looking for in problems that are lump sum, it's not hard, but when we have payments, when payments are involved, it can get very complex, and solving this is not so easy. And that's why we're going to use the calculator to help us, all right? So this was doable algebraically. So now let's use the calculator to solve to get the same answer. In using the calculator, there's one catch, right? You have to keep track of the signs. Remember, 900 is being spent. That's cash outflow, and 1,000 is being earned. So 1,000 is cash inflow, revenue. So what you're going to do is enter all these with the correct signs and then ask for to compute the interest rate, and you'll get the result. So 2 periods. I don't know the interest rate. I'll leave that blank. Oh, I should clear TBM for a second. Clear TBM. And 2 periods. Interest, I don't know. PV is 900 with a negative cash outflow. No payments. And 1,000 is cash inflow. And now I'm going to compute the interest. And there it is, 5.409. Let me know if you have any questions about that. And the question here is, can you solve this analytically without financial calculator? Yes, because we just did it, right? Any questions? Trust me, it gets much more complex than this, all right? Just let's get this right and solid basis for using your calculator, and you'll appreciate the power. For people who ask for the notes, I will send them after the class, because otherwise I don't have enough time. Okay. The final variable for the expression, I'm going to give you the future value, the present value, the interest. Now you need to find T. So how many years does it take an investment of 1,000 to become 10,000 if the rate of return is 8% per year? What do you get? I'll let you do this one.
Is it 29?
Very good. So how'd you do it? With your calculator?
Yes.
The finance calculator? Very good. So you used
I used a rate of 8,
uh-huh.
and the present value will be 1,000, and the future value will be 10,000.
But negative, right?
Yes, negative because it's a outflow.
Exactly. So that would be a negative, that would be a positive with 8%, and you should get 29 years. Very good. So that's what we did here. Now, can you solve this algebraically, analytically? So let's do that on the side here. So it would be 10,000 equals 1,000. Now, you don't put the negatives and positives in the formula, right? Just for the calculator, you use those negatives and positives. So I need to cross multiply, and that will give me 10. Well, I'll just show the steps. So this would be 10. And then to simplify an exponent, if you remember, you have to take the natural log of both sides. And because the natural log and the exponential function kind of cancel each other out, I'm left with this. And then, so t is equal to ln 10 divided by ln 1.08. So another reason why you want to learn how to use your finance calculator, but you should be able to do both, okay? For this class, you should be able to solve problems analytically and using your finance keys. So to put this in your calculator, it's ln 10 divided by ln 108. I think you have to put the number in first. So I do 10 ln divided by 1.08 equals, there you go, 29.92. Do you want to see it again?
Yes.
Yes, okay. Okay, so you have to press the number first. So it was 10 natural log divided by 1.08 natural log and equals. Here's the steps. So we haven't talked about how many things we can complicate this problem with, but very basic time value of money relationship is the basis of finance. Okay. Anybody get a different answer? Okay, ready? Okay, so we have one relationship, but you can see it in two ways, or I could isolate for all the different variables using the analytical solutions, but I'm just presenting them both like this, just to remind you that this is the accumulation factor, 1 plus I to the t, and the discount factor is 1 over 1 plus I to the t. We did not complicate this problem by playing with the timeline, but that could further complicate things. You have to make sure, as we did, that we were going from end of period to end of period. Okay, so in all of these problems, whenever I wrote a number down, we assumed that was the end of the period. Okay, so I wrote $1,000 down. That was the end of period 0, or the, the beginning of 1. And when I wrote 10,000 down, it's the end of period T. So I didn't play with the perspective. Okay, those were end of period statements. You could also write it or interpret at the beginning of certain periods. You got to read carefully to make sure that the amounts, the lump sums, I'm saying lump sum, falls it falls at the same point. So this is at the end of 0, this is the end of T. And we count T periods, duration. Or it could be the beginning of period 1 to the beginning of period after T. It still would have the same calculation, same formula. Just got to be careful because these formulas are written in terms of end of periods. All right. Okay, any questions so far? All right. Okay, so here's a question. Talked about the basic time value of money relationship. How does that affect an investment decision like this? You believe that if you buy a hotel for $3 million today, you can sell it in 5 years for $4 million. So let's assume that that's true, okay? That you can. The interest rate is 8%. So that's the rate that you're willing to trade off $1 today for. Should you buy the hotel? So we're going to explore what's called the net present value rule, but using your intuition and what we've discussed so far, how would you answer this?
I would say no. I mean, I tried it doing the calculation on the calculator, and it seems like I got for a future value a number greater than the 4 million that you'd
Okay.
be able to sell it.
Okay, so good. So when you did that, you put a 3 million in as your present, and then you asked for the future value, right? So you were comparing 3 million outflow as though you invested it in financial markets. So there's a prevailing 8% available to you in financial markets, and you saw that you can get more than 4 million. So that's perfect. That's what you're going to think. You're going to think, well, what's the next best thing I could do? There's the hotel, and then there's the 8%. Those are two different investment opportunities. So very good. Let's see how I'm going to put it on here. I don't know why I have a black background. Give me a second. See if I can change that. Wait. So what you did was you said to buy the hotel. Oh, sorry. Let's say this is the option. So this is the option of buying hotel. And then the alternative is invest in financial markets. So you're going to find someone who's going to give you 8% return. So 3 million after 5 years becomes future value 5 million. And what did you get?
I got 4,407 with 984 with 23 cents.
Thank you. Okay. So this looks like it's better, right? So this is how you're going to think from now on. Because of the existence of financial markets, there's always something else you could do, right? There's always whatever investment you face, you have to set, you can compare them to each other. But if I just look at one at a time, I compare it against financial markets, and I shouldn't do that. This interpretation is put all together in one expression when you compute the net present value. Okay, the net present value, rather than looking at the future value of your potential cash outflow, we turn the numbers into the present. We convert the cash. So to put these two sentences together, these two rows together, all I'm going to do is convert the 4 million into times $0 and look at whether it offsets the cost. So this is the convention in finance, is to use present value. Does anybody know why? So you got the answer, and that's good. But like I say, the convention in finance is to use the net present value. And the reason is that we have a better handle on what dollars mean by understanding their purchasing power today. And further than that, not only understanding their purchasing power today, we can understand what we can leverage against them. So if I know so much money is coming to me in the future, what could I do with it today? It's that same idea of what are things worth to me now? Because now is when I'm going to make a decision about the future. All right, so the net present value works like this. So this is spent today, but then it's offset by the 4 million to be received in year 5. Well, what's the value of an amount to be received in year 5? I have to discount it 5 periods. So this is how, in general, we write the negative, let me see my notation. Okay, cash flow, at initial cash flow I'm going to not put a negative because the initial cash flow will be negative in an investment. And then plus, I have to keep looking at my formula, sorry. Okay, we're just going to say the present value of future cash flows. So cash flow. The CFO is less than 0 for investments. And what does your NPV become? Peeking again. This is my NPV formula. I'm going to show you how to use your calculator to punch in this new formula. But essentially, it's the discount formula for the time value of money relationship plus the investment. Anybody get a number?
Would it be 277,667 with 21 cents?
Say 277.
667.21.
Mm-hmm.
I'm not quite sure.
Is that what everybody gets? Other people get? So you could use the you could use the present value, finding the present value for 4 million for 5 years at 8%. I'm going to clear TBM. So I could say 4 million, 6 zeros, no payments. Usually I go left to right, so not to confuse you. So 5, 8, and then I want PV 0, 4 million. 1, 2, 3, 4, 5, 6. And I compute PV. So that's just the present value, which is less than 3 million, right? And then I add 3 million to it. And that's it. So you're right. So that's the long way to do it. You can see on your calculator, there's in the middle, second row, there's NPV. Let's use that instead. So let's hit NPV. What do we see here? NPV. So if you hit NPV, you should be able to scroll. There's a bunch of things in here. Okay. Interesting. All right, so there's numbers in here already. Okay, so I already have in the worksheet, this on the second row is the worksheet for cash flows. So CF stands for cash flow. If I hit cash flow, you see there's numbers in there already. I need to clear the worksheet. To clear it, I have to hit second and clear work. So now it's empty. So you can think of it like an Excel spreadsheet. It only serves one purpose, calculating well, it calculates a few different things, but it just holds the cash flows for problem. And I want to enter 3 million as an initial investment, so negative, and I hit enter and scroll down. And then for my first cash flow, well, nothing happens for 4 periods, right? Nothing happens for 4 periods. So I'm going to tell the calculator that nothing happens, 0, enter, and then I'm going to say F is frequency. So for 4 periods, nothing happens. Enter. So 4 periods, nothing happens, and then I get $4 million. 4, 1, 2, 3, 4, 5, 6. That will be in the 5th year, and there's just one of those, and that's it. So those are my cash flows. 3 million, then 0 for 4 periods, and then 4 million, the 5th, end of the 5th year. So any questions about entering the values for cash flows worksheet? Now what do you think I do? Intuitively, going to hit compute, NPV, and it asks me for the interest rate. So I enter 8, enter, scroll down, it says 0, but I think I have to hit compute again. And there you go. Okay, who wants to see that again?
Me, please.
I
Okay,
wish to see
so
that again.
okay, so I'm going to start fresh. I'm going to clear my worksheet. So as long as you're in the worksheet, you can clear it. See, I didn't clear it. I have to be right here on CF. Second, clear work. So it's clear. So I'm going to enter my cash flows. Initially, I spent $3 million. So 3, 1, 2, 3, 4, 5, 6 with a negative. Enter and scroll down. And then if you go back, if you look back at the notes, let's see here. Nothing happens for 4 periods, 0, 0. So there's no action for 4 periods. So I'm going to enter 0, enter, and I'm going to say frequency is 4 periods. So F is 4, enter. And then in the 5th year, there's going to be a sale of the hotel for $4 million. And I enter it once, and that's it. I'm done. So I'm going to review my numbers through million. 0 for C01 for 4 periods, and then 4 million in the 5th. So it keeps track for me. And then I ask it to compute NPV. So compute, oh, sorry, I hit the wrong one. Compute NPV, and I say 8%, enter, and scroll down. And then I have to ask to compute again. So if you don't have this calculator, you have another one. It's a little more complicated, but once you learn, it's not so hard. The HP is similar, HP 10B. All right, any questions? All right. This is a 2. And this was a negative, right? I erased it. So the rule, the NPV is a convention. We calculate NPV, and so doing, we're offsetting, we're bringing the comparison of our investment against the opportunity cost or the opportunity of financial markets at 8%. And this is telling us that it's not worth it. So the rule is that when NPV, NPV greater than 0, you only invest if NPV is greater than 0. If it's not greater than 0, do not invest. So in this problem, do not invest, right? Or we say do not buy the hotel. It's like an investment, but this is known as the net present value rule. And it is our first approach to valuing investment opportunities. It's how we can value investment opportunities. Obviously, if there's one interest rate, it's kind of easy, but and we already know what it is. So we compare it against our next best option, investing in financial markets. All right, so let's see about another opportunity or another scenario. You believe if you buy a hotel for $3 million today, you can sell it in 5 years for $4 million. That's not it. Oh, this is these are all the steps. These are all the steps for the calculator. What I did was combine these steps and put 0, enter, down, 1, enter, down. I put 4 instead. And I skipped entering all of them. Into frequency. So now I'm going to change things a bit. And rather than just buy the hotel, you're going to rent out the hotel and earn rental income of $200,000 in the 3rd and the 4th year. Now, is it worth it? Are the $200,000 in each of the 2 years offsetting the loss of 277,000? So why don't you try that one and tell me? So in this case, you're going to enter only 2 zeros for these years. And then for the 3rd year, 200,000. fourth year 200,000, or do 2 years of 200,000 and then 4 million. So tell me what you get.
Is it 26,000?
Yeah, something like that. It's positive,
Yes.
right? So it tells you that you should invest, right?
Yes, because it's more than 0.
Okay, I got 28,000, but you were close. So try it again,
28. Okay.
but you were close. So what we're doing is converting every cash flow to a time 0 cash flow. That's effectively what we're doing. We're repeating the time value of money discounting for each term so that we can add time $0 to time $0. Anybody else get the same?
$28,105.20.
Exactly, yeah, 21. Okay. All right. Anybody not get it? Everybody's okay? Julio got it? Very good. Your decimals are a little bit, oh no, you got it, Okay. So any other comments? All right, so we learned about the net present value and a net present value rule. In this case, it's positive now. By renting it out and earning rental income, we offset potential loss and make it worth investing in. So what we're talking about with alternative investments, so we talked about buying a property. What about back to the idea of potential returns and what what would this be worth to you? What's a fair price? Or what would you be willing to pay to earn 1,100 in 1 year, 2,500 in 2 years, and so on? What would you be willing to pay to get that? And that's possible if you invest in a mutual fund. A mutual fund puts you in a pool with, well, in a group of other people who've also invested. And then you get, as the fund, because the fund is large, the portfolio manager, the manager of the fund, is able to access a variety of investment or securities or opportunities that otherwise just an individual investor wouldn't have access to. Okay, so how much the amount that you invest determines how much you're going to get out of the fund. And let's say you're looking at these being your possible returns, or you were promised that you would make these returns over time. What would you be willing to pay for that? In other words, what would be a fair price? Well, we need to use the same approach as we did with the net present value rule, except the difference is that we don't have an initial investment. We're trying to figure out the initial investment. Okay, but we're going to use the same function on our calculator in a slightly different way. Here is the formula for what we're entering. We need to find out what CFO is, the initial cash flow. And we're going to offset the initial cash flow, what we're willing to pay, by the returns, dollar returns, discounted to time 0. And to be fair, whatever we make should just offset what we invested. So this could be 0. By doing that, we can rearrange this, and now we have a value for our initial investment in our NPV formula, or in our NPV, to put into the NPV worksheet on the calculator. So if you put a 0 in there, you're going to find the fair price as your NPV. It's what you would be willing to invest. Remembering that CFO is a negative value, it's going to be exactly the NPV. So let's try this. Why don't you try this? This will be, you know, it says CFO here. This is the first thing you put into your calculator, a CFO. This would be C1, C2, C3, C4, C5. What do you get? We refer to this as a mixed cash flows problem. And you're going to see why when I show you the next slide. Anybody? Not yet? Nobody? I gotta do this. Check the chat. All right, let me try. All right, so I'm going to clear. So I'm going to go into the worksheet and second clear work to wipe out what was there. Now I'm going to put a 0 in the initial spot, and then I'm going to put 1, 1, 0, 0 one time, and then 2, 5, 2, 5, 0, 0 one time, and then 3, 4, 0, 0 one time, and 4, 0, 5, 0 one time, and 1000. And I'm done. Oops, hit something. All right, so everything's there. 0, 1, 1, 0, 0, 2, 5, 0, 0, 3, 4, 0, 0, 4, 0, 5, 0. Okay, and now I'm going to ask for NPV. I have to put in 8% and compute. Anybody get this? So this investment is worth $9,518. Very good, Adamaris. $9,518.34 or 35 cents to me. If it's offered for less, I should buy it, right? It's the only opportunities available, that investment or financial markets. So the existence of financial markets forces me to choose. And that's what I choose. Okay, so whatever you get out of the NPV, putting a 0 here is actually how much you have to invest. So this is your investment. Remember, CF0 is a negative number. It's your initial investment. So try that. Oh, another 15 minutes. No questions? So what I can do, I'm going to put up these slides, but I can also put up the markup slides. I can put them up. So I don't know if that helps. You can summarize what I did without watching the video again. Yeah, yes. Sure, as long as it's easy, because I don't know, I have this black background. Not sure how that happened. Okay, next, ready? Do you need more time? So it's worth paying at least, I mean, at most, $9,518 to get this deal. Notice at 8%, you're paying for what you get. You're capturing the 8% return. You're compelled to do it. So this is the general formula for mixed cash flows. Notice I still use the CF0. This is a negative. I'm going to say it again because it's investment, right? And then we have the different cash flows over time. And this is just general formula to remind you what we did was note we put 0 in CF0 and then we interpret the NPV as CF0. If that makes any sense. So this is how you would handle mixed cash flows. But what if the cash flows are infinite? What if, I mean, I only entered 5 and it seemed tedious already. Imagine if cash flows are, there's many of them. Like let's say you were getting payments or expecting payments monthly for years to come. Or what if it's infinite? We'll talk about scenarios where you can realistically imagine infinite cash flows in the future. And in that case, we need a better method. A calculator is not going to suffice, right? Because we'll be entering, we'll be entering till the end of time values. So another question is, how do we, can we have a simpler way of doing this if the cash flows are the same amount and not different, not mixed? So that's what we're going to deal with next. Here's an example of infinite cash flows. A British consul bond is a bond that is available. I have to check if it still is or has been available in the United Kingdom. And it pays $100 a year. Okay, so these are available in UK by the government. And they offer $100 per year forever. They are known to, this one that we're going to discuss has a yield to maturity of 5%. In other words, it has an implicit interest rate. So this is the term. Remember, I told you that interest rate has different terminology. So when it comes to bonds, we call for bonds, we refer to the interest rate as yield to maturity. And it's implicit. So what's a bond? Sorry, I'm jumping about what bonds. So what are bonds? Does anybody? So basically, this is an example of a bond. This is a government bond. So the government borrows money from the public, can be foreign or domestic, and they use the money to operate, right? To operate projects for the general operating expenses of the government, and then they have to pay whatever they promise to the bondholder. And a bond is structured with a rate of return or a payment. It can come as a set return. In this case, it's 5%. It says 5%, which works out to be $100 per year. So what is that worth? What would you pay for that? What's a fair price for that? So it's just it's a loan that is made by the public to the government. Now, bonds can be bought by the public. They can be bought by pension funds can buy bonds. So institutions can buy bonds. Yeah. So how would we figure out the price here? Anybody know? Are we going to put $100 every year for 5% in the NPV formula of our calculator forever? No, there's got to be an easier way, right? So here's the timeline. This is the timeline. And the timeline goes indefinitely. It goes on forever. What we're going to do, instead of looking at it like we did the mixed cash flows, in this case, it's not even mixed. They're level. They're the same amount forever. We're going to think about it a different way. We're going to say we want to find out what the price is. That would be PV0. And whatever the price is, that amount pays $100 every year. So it's like what you're getting is putting this money, investment, into a pool or a pot, and then every period, every year, you're getting 5%, which makes 100. So that pretty much captures all that's happening, because I was given the interest rate. This goes on forever. This goes on forever, and it's just leaving the amount there, and giving the $100 to the creditor or the bond holder indefinitely. This is the relationship. So this is a different kind of relationship. So this is new. So what would the price be? What do you get? We're going to talk about investment opportunities. We're going to talk about stocks, and we're going to talk about bonds as financial securities. Anybody compute it? Yeah, 4 minutes.
2000s.
How much?
2000.
Okay, 2000. So look at that. It turns out that $100 received forever is not an infinite amount of money. It's just $2,000. Does that make sense? Why does it make sense? The answer is because of the time value of money. If you think about it, $100 discounted to time zero at the end of the first year is really $95.23 today. $100 at the end of the second year is worth $90.70 today. Notice it just goes down, down and down and down. Eventually, at some point, and I'm not sure where, off into the future, now this bond, you can own this bond, earn $100 a year until the end of your life, and then pass it down to your children, and they could continue to earn, right? So this idea of forever needs to be taken seriously. So at some point, because this is going down, you're just adding zeros. And you're going to be adding zeros after a point where it's already become $2,000. So everybody follow this chart. So this is called a perpetuity. These payments are in perpetuity, means forever. And mathematically, because of the time value of money, because $100 1 year from now is worth $95.23 today, and so on, eventually I'm just adding zeros, and that happens after these sum to 200. So we have a simplification formula known as a perpetuity for the setting where we have cash flows that are the same. Notice my notation here, C1. So that's your initial cash flow, and then you keep getting the same cash flow, and you get it forever. Notice, and I emphasize, obviously C1 is important, and that's forever, divided by I from the logic that I gave you. But you could prove this also using mathematical infinite sums equations, but I'm not going to get into that. I'm just going to use this simple argument that I made on the other page. What you have to be aware is this formula only applies when the first payment is 1 period from the valuation. Okay, there needs to be a difference of 1 between this and this subscript. So there has to be a difference of 1 for the formula to apply. Otherwise, it's a different formula. Okay, it's going to be slightly different. So it's 8:45. I'm going to share these notes and the markup notes, and you can work ahead. You can read chapter 1, and I'd like you guys to read about the issue I have with the textbook is like they talk about the in-depth topics like later in the chapters, but they introduce them early. So feel free to just use the textbook as a reference and go into the index and find out what does they say about bonds, what do they say about stocks, what do they say about, okay, so use it as a reference, and that will help you a lot because there's a lot of terminology in the first chapter even that I don't think it's justified if you don't have any background in finance. So you might have to go to other chapters in the book, and don't even hesitate, just do that. Or use Investopedia. You can use Investopedia, the internet. Very good for definitions. And we'll talk about chapter 1, and we'll pick up here on next class. Any questions for me? Okay. So have a good night. See you next week.
Thank you, Professor. Have a good night.
Mm,
Bye.
Thank you. Bye.
Bye.